Can you guys hear us here?
I just started to record.
Yeah. Okay, we can hear you. Go ahead and have the other students. What I'd like everyone to do is introduce yourselves. Have everyone introduce themselves, and then give us the title of your project, and then just go into what you're doing. So as you go around the table, we'll see who we can hear and not hear.
All right, Willie, you want to start?
Okay. My name's Willie. I don't know. What do you want me to say while I'm introducing myself?
Oh, just
What year are you in school?
yeah,
Oh,
what year? And also if you're with the high school, or if you're the college helper. I don't know. The
oh,
college students here too?
okay.
I think so.
My
Yeah.
name's Willie. I am a freshman in high school.
And what do you want to do when you're out of high school?
What do I want to do when I'm out of high school? Preferably win the lottery. Other than that, probably become an engineer.
Very good.
I know, I agree.
Yes.
Okay. My name is Henry. I'm a junior in college, and preferably I would like to graduate here with a mechanical engineering degree.
I'm Alper in high school. I'm junior, and I want to be software engineer in the college or the university.
I'm Ilya, and I'm a freshman at Platteville High School. And after high school, I want to play soccer collegiately somewhere.
I'm Kenny Madden. I'm doing my master's at Purdue University, and after I graduate, I would love to work in mission design for NASA.
Cool. And who's
So-
over there in the back?
Oh, we got two more.
Two more.
My name's Aiden Runkle. I'm a senior here at UW Platteville, studying mechanical engineering.
Excellent.
Okay.
They asked for you.
Oh, Aiden. We take that go.
Okay.
Yeah, are you guys able to hear everybody's names and stuff?
We
Yeah.
heard it. Yeah.
You bet.
Okay, great. Awesome.
All right, and I'm Wyatt. I am a junior here with mechanical engineering major and marketing minor.
Excellent.
And Wyatt, you're rocking a great mustache.
Okay.
You guys want to maybe introduce yourself so everybody here can kind of know who you are and
Yeah.
Sure. I'm Glenn Johnson. I work at Johnson Space Center in Houston. My job is to come up with these projects along with my mentors and some of the engineers and astronauts for all the projects. Okay.
Yeah. I'm Nancy Hall. I am the regional mentor for NASA Glenn Research Center. I'm in Cleveland, Ohio, and I mentor schools in Wisconsin, Minnesota, Missouri, Ohio, Michigan, and parts of New York.
I'm Flo Gold, and I am in Montana. I live in Montana, and I am the regional mentor for too many states to mention, but but I used to do Platteville, Wisconsin, and I always loved visiting Matt Hare and his students. So that was many years ago, maybe even 13 years ago, maybe even more.
And I'm Dave Schlichting, and I didn't win the lottery.
You never know, Dave.
Yeah, I know, because I don't ever buy tickets. So I'm a retired astrophysics and space science educator. I've been with NASA HUNCH for about 15 years now. I'm retired and mentor in the Colorado area.
cool. Right.
Okay. So what are you guys working on?
Yeah. And if you guys want to show things, you can change the video here. You want to get close up.
Yeah.
Just select integrated camera, and it'll then you can use
Oh,
it.
cool.
So, otherwise we'll put you back.
Everybody. Well, we started most of this electronically, and
Okay, which project are you working on first?
we did the jumping robot.
Okay.
And we did it most of it electronically just to start, like no goes, and kind of just like figure out like a basis, and then we came to like the design phase. And
Okay.
here's
Yeah.
some.
And then one quick question: are you guys doing the entire robot, or are you picking because with the robot, I didn't want to interrupt you, but some teams are doing all the robot, other teams are picking like two parts of it. Are you guys doing the whole thing or just one part?
We're doing the whole thing.
Awesome. All right, go for it.
So here are some of our first designs.
Oh, there we go. Yeah, rotate that around a little bit there. That looks good. Yeah, come on, move up just a little bit.
Scooch up
So
there,
just-
really.
There we go.
Exactly. So fill that and try to fill it.
Okay, tell us about it. Tell us what we're seeing.
So we kind of just we were thinking in the beginning, we kind of wanted a way to like protect the robot. So we were thinking like around 3 legs, like that kind of went with a no go. And we were thinking like 3 legs, and it would have like a 270-degree torsion. And once it jumped off, the legs would come around and kind of protect it after it took the picture and like fell. And we kept trying to test that, and like farther and farther into it, we realized that it might not work as well as we thought it would. And so we kind of shift. Now we're thinking about we're gonna do a piston.
Yeah, hold up. Here. Now we're kind of switching over to a piston because it would be hard for us to wind up all the torsion springs a lot. And it would just be easier for us to wind up a piston, like right there. And then just have it one piston, pull it down, and then it'll launch it up. And then we had to figure out how much torque or how strong the spring needed to be. So we did a bit of the physics about that on this paper, talking about the conservation of energy and like, shoot, sorry, I didn't realize that. I
Wrote out the equation.
Okay.
Yeah. So we just like wrote out the equation, and then we figured out that we needed to have thing in K or the
Austin, yeah.
yeah, the constant to be 207.36 pounds per feet of the spring, or 17.28 pounds per inches, which was a lot, so to say. But that's with like how big our constant was.
And going back, kind of our like finalized design, we have this. So first we have this gear just to wind up the mechanism. So you can see it kind of goes in like this, and you'll crank it, and this is how the whole robot will actually be wound up. And then after that, it goes through the robot, and it gets to the point where it's winding up this piston. And so it's cranking this gear here. And once this gear reaches the face or the side of the gear that doesn't have any of the teeth, then it's gonna release, and that's what's gonna send the piston down to make it jump.
Very smart. I like that.
And then we haven't completely like figured out the exact gear mechanism we would have in like the middle of the process to like lower the weight forced onto the gears, or where you won't have to twist this as much. But we have the beginning and the end, and we figured out it was possible for the most part. So
Very good. All right.
How
So
will
I
it
see that you
release,
printed
guys?
out. Oh, I'm sorry. Go ahead.
How will it release? Is there a clutch or something that'll disengage that wheel?
Are you talking about like how will the piston go, or like how will you release the after twisting?
Yeah, after it's cranked up, you got to remove that wheel so it'll release, right? How are you going to do that?
Well, I mean, if you're talking about like this, we have like the key or whatever, and then we 3D printed this. I don't know if this will be our final one, it might be. But you put it in, you crank it up, and then you just take out the key.
Okay, got it.
When you say are you doing this manually, or are you going to have a control that's going to turn it on or set it?
As of right now, the plan is for the astronauts to just go and crank it themselves.
That's why it's okay.
Well, That's
Okay.
why it's so big, so to say. And then you just take this key out and then just keep it with you. And then once you need to rewind it up, you just put it back in and crank it up again.
So can I offer a thought to you guys?
Yeah.
If the astronaut is standing right next to this rocket when he removes that key, he or she, right? How can you assure the fact that this thing doesn't come up and like smack into their helmet and crack their shield?
Yeah. So explain how your torsion spring keeps it potential energy, and when you pull the pin, it'll start winding the mechanism.
Yeah.
Okay.
Yeah. Okay. So you're gonna have like a torsion spring kind of in here that will
Okay.
hold it into like potential energy. And then when you go away, you'll kind of like pull this small little pin, kind of like on trailer hitches or whatever, those types of things. You just pull that after you're done winding it up. And then yeah, after a certain amount of time, it'll just launch, and that should allow you to get to a safe distance since the pin will keep it from actually
Okay,
rotating.
great.
That sounds good. Now you realize that we want this to operate autonomously as much as we can at some point. I'm okay with, some of your early version, you wind it up. And actually, I think that's actually a really good idea is to start off with that. But at some point, you want to start working towards making it as autonomous as you can. Does that make sense?
Yeah. Just like the motors it would take to like move up would be quite expensive, so to say, for our prototypes.
That could be true.
Yeah.
And it's a matter of
Scale it
finding
down.
What?
Can you kind of scale it down, guys, so that the motor let's back up for a minute and talk about the requirements. What kind of height would you guys like to achieve?
About 3 feet.
Okay.
And that's what our physics sheet or whatever, that's what we put the height to be around.
Okay. That's a prudent idea. We originally started off with 10 feet, and it's been revised so that the minimum height now is 3 feet, the maximum is 10. Frankly, in a lot of places, I don't know that we're going to have 10-foot ceilings in a lot of places where we're going to be, testing these at CDRs. So I think that 3 feet is a great objective to shoot for. But here's the advice that I've been giving to teams around the country. When it comes to the CDR, the requirements that we've put in state that once the robot is powered up, it should have some type of a delay so that the people can move away from it. And you've already addressed that point. It has to launch, come down, and then it has to be able to launch a second time. And that means that ultimately it's got to be able to self-right itself once it's on the ground. It's probably going to be laying on its side. So there has to be a way to orient it so that it can make a second launch. And that means some level of autonomy, right?
Yeah.
Yeah. So, and lastly, of course, there needs to be a camera that can capture an image and then transmit that image either to a cell phone or a laptop or, some device, either by a Wi-Fi hotspot or a Wi-Fi connection or a Bluetooth. But I will tell you that I think the biggest design challenge for this project is self-writing and making that second launch.
Totally.
And when you think about this, if we expand this out to its actual purpose, the robot is designed as a way of doing reconnaissance of an area. We have lunar orbiters that are taking great images, but the resolution is not as good as what they're going to need. So astronauts need to be able to look at an area and understand the surrounding terrain. Now, on the moon in 1/6 gravity, if this launches, and let's say it achieves a height of, I'm just going to arbitrarily say 100 feet, right? But it doesn't go straight up and back down again. If it flies in any kind of a parabola, it might come down some distance from where that astronaut is located. And for them to then have to go over to that robot, traverse that area and wind it up and launch it again becomes a time consuming and arduous task. So the idea behind autonomy is for this thing to be able to launch and take multiple images of a surrounding area so that they can then, kind of scan it and understand what the geology is, what the topography of the ground is, etc. So
Hey
again,
guys,
I
hey
would
guys,
encourage you to think about what's going to happen when this goes up and comes back down and it now has to launch a second time. That's a big part of this design challenge.
Yeah, we have.
There would be a one in the gear
Yeah,
mechanism.
Glenn, go ahead.
how big do you guys want this to be?
Well, I mean, when we did the physics kind of worksheet, we just put it at 6 pounds. Hopefully it'll be less than that. But as of right now, we want our higher limit to be 6 pounds or lower.
Okay, and that 6 pounds is at the body or everything? Because remember, there's multiple parts to the robot. You have the energy, the control system, and the power system. That's why I asked initially which parts you were doing.
That 6 pounds would be like the full robot itself.
Okay, so just the robot body would be the 6 pounds.
Well, yeah, with the gear mechanisms and stuff inside of it.
Okay, that's good.
Well,
Second
and part of what I mean, when you watch those videos, 6 pounds would be really big. Is there a reason why you want to go that large?
Well, we just put an estimate at 6 pounds since we haven't completely figured it out. So when we get our springs at a certain weight, even if it goes under that, so we pretty much put a high estimate. So if it goes under the pound limit, it would still work out perfectly fine, if not slightly better.
Okay, so you don't want to go over 6 pounds based on what the other needs are.
We just put it at a upper estimate type of thing.
Okay. 6 pounds sounds pretty heavy. I wouldn't want 6 pounds landing on my head as part of what I'm thinking about it. But let me share something with you here. Okay. Can you guys see this okay?
Yeah, it's coming up. Yep.
Okay. So just a comment for you. If I go to Spark Fun Electronics on the internet, I can find some really small geared motors that might be able to help you guys out a little bit. Another one, let's say if I said a small camera.
48-to-1 gear ratio. Huh? That's sweet.
Right.
Oh yeah, that was nice.
Here, like this one. Well, that one's kind of pricey. I think I can get smaller ones for cheaper.
Yeah, I was gonna say I've seen a lot.
You definitely can.
Have you? Well, while Glenn's doing that, have you guys figured out what type of control system you're gonna use? Are you using Arduino, Raspberry Pi, or something else?
No, I don't think so.
So with their design, their intention was to make it fully mechanical, and by winding it up past more than what the torsion spring would be for one launch, it would self-launch itself over and over mechanically.
Yeah.
Based on the amount of turns you took of that key.
And and kind of how you talked about it self-centering itself and being able to launch twice. We have a gyroscope, and this will kind of in the air, this will keep it kind of level and help straighten it out. And then the body itself we designed as an egg shape. So if there's naturally like if there's more weight on the bottom, it's gonna roll back in the egg shape to kind of like the sitting position. And then we also have a Bluetooth camera. We're trying to figure out how to connect and
Well,
Con-
that
and
sounds awesome. Where did you find that one?
this camera,
Yeah.
Amazon.
Okay, that's cool. Okay, let me see if I can figure out how to stop sharing here. Where'd it go?
Google
Oh,
search
stop sharing.
few links.
Okay. And I think that that's wise. You got some great ideas in there. Um, so I like your idea. So Dave mentioned the writing itself as being one of the more complicated things. I think he's right about that. I think the other one is just figuring out how to compress your spring and then release it. And that's a really difficult one because you got to figure out some kind of a gearing or release mechanism to be able to let it go. Do any of you guys fish by any chance?
Yeah, I do.
Little.
Okay. And so when you reel it in, right? You're engaging the gears, but then when you flip it over to be able to cast, you're releasing the gears.
Oh
I
yeah.
wonder, I mean, if you were to look at that mechanism, that might be something to help out as well. Not that I don't like your idea because that actually works as well. But when you're trying to get something that's small, you might look for some of the other things like that as well. Okay?
Okay.
Thank you.
Um, and I think you had said it two different ways, and both of which I think have value, where you have um you've got your handle and it's into the gear and you wind it and then it gets pulled out. And the other way I thought you said it was you remove some teeth. Is that right?
A pen type of thing.
No,
Uh-huh.
that's for the piston. That's
Oh, okay.
for winding it
Oh.
up. And for the piston on the gear, sorry.
That's good. That's my bad.
Something's too complicated.
So that's your start mechanism. That's
Yeah.
action.
So guys, one of the things, and Glenn
Oh,
just shared something
hold on,
with
let
me.
him finish here.
Oh, go
Explaining
ahead.
how that works.
So yeah, that's just kind of for starting it. And this is right here. This is how the piston we're hoping to plan out it's gonna be working.
Yeah.
So there's just a gear without, and then a face of it has like doesn't have teeth. And once it reaches the side with no teeth, then it'll release on the pin.
Okay. And I think there's some good value to that. So I want to see how you guys work that out because for both of those there's some difficulties, but I think that you can work through them. Excellent thinking, guys. Keep it up.
Yeah,
Thank you.
exactly. And guys, I was just going to comment, Glenn shared something. If you Google Raspberry Pi, there are a lot of systems out there. For instance, I just pulled up, I know a lot of teams are using a Raspberry Pi Zero, and it's got a camera with it. And it's like $30 for the whole system, right? So again, there's probably some things out there that are well within your budget, and depending upon how many of you or who on your team may ultimately end up doing some kind of programming to set your board up. Arduino is another option. They're actually a little easier to program than Raspberry Pi, but it's not that big a deal. But again, if you have a limited budget, and I would say that most teams do, I would definitely look at something like Raspberry Pi. Just check
For
it
the
out.
controls. Yep.
Okay.
Now, just as a comment, if you go on to the for the like the camera or whatever on that SparkFun page, there's also the code for how to run it in Raspberry Pi or in Arduino. So you don't have to learn all the coding. You can pull the code off the website. Does that make sense?
Mhm. I would.
That's not cheating. That's using your resources.
That's what you call commercial off the shelf.
You bet.
But I thought you were going to make it all mechanical and not use any electronics. Is that right?
Well, that's for like the mechanism, but for the camera itself, we're still going to need to have a little
Okay.
electronic, but
So what do you guys want to do next? What do you think your next step is?
probably figure out somewhere like how to connect the start and the end, like what type of gear mechanisms we would need.
Mhm.
Okay. And you had mentioned a torsion spring on that. Is that right?
Yes.
I think that's also a good choice. Have you looked for the sizes of springs that you want?
Not for the torsion spring that would be holding the start thing yet.
Okay. And just a thought for you. Um, I can look up online and find all kinds of springs and things like that. But one thing that helps me a lot is being able to squish it or twist it or whatever and help me understand how big of one I need. So, for example, talking about a torsion spring. So I've got a rat trap, okay? And you can pull off a couple of torsion springs there and get those for free if you want. Be careful with it; they'll smack your knuckles pretty hard. But the other thing is, if you go over to the hardware store, if you go to Ace Hardware, there's always somebody looking to help you. And if you go in there and say, "Hey, I'm looking for springs," they'll send you over to this bin, and it's got like 20 drawers, and each drawer has 20 different types or 20 different sizes of springs in it, and you can sit there and play with them. It's a really great way to explore what to do there, and you can find exactly the size spring that you're looking for. Does that make sense?
Great
Yeah.
idea.
Yeah.
Right.
Any other thoughts?
Yeah, Glenn, I love how you have that
Looks like
sitting
you're
back
frozen,
there.
guys. We
A
still
lot
have
of things sitting
connection?
here waiting to show.
Do you have any questions for us?
Hey, Matt, can you still hear us?
Yeah, we can hear you totally.
Oh, okay, sorry.
Nope.
Your screen was frozen there for a second.
Yeah.
Yeah.
Well, I appreciate the college kids working with the high school kids. That is so
Yep.
awesome. Thank you so much for doing that. This is a complicated project, and you need to actually, which is suggested on the PowerPoint, divide and conquer.
Yeah.
So that will work real well. Have you divided into different teams to work on different parts?
Yeah, for the most part, two of our members aren't here today right now
Mhm.
because we're having quite a bit of a snowstorm right now.
Oh no.
Yeah, we
Good
can understand.
Good for
They
you.
wanted to get home before the
Okay.
got too bad. So
Drive carefully and slowly, guys.
they made the smart decision to not
Not
be here
come.
today.
Well,
But
and you know what? They could also zoom in. So this Zoom, anyone
Absolutely.
can add to zoom in next time. Does that make sense? They could zoom in from their home.
mm,
All right.
Any
Okay, I was
thoughts
gonna
or
say,
questions, guys? Oh, go ahead, Nancy.
no, I was gonna say if you have any other questions, so we can get next. Nope.
All right. Have a
All right,
great
let's
week.
yeah, drive
Thank you.
safe.
Good job, guys. Keep this up.
Drive safely. Thank you.
Did you try to?
You know, it'd be a lot funnier if I had a dead rat in the trap when I came to show it, you know.
That would not be funnier. I didn't know it was still snowing there, Matt. You're muted.
Oh, we can't hear you.
You're muted.
It's like
Like
dusting. I mean, it's
Yeah,
not
yeah,
like
yeah, just lightly.
yeah, not even like
I wanted to get pieces of
Yeah.
space.
yeah, I have one of those rat traps in my classroom in kind of a squirreled away corner, but I have an old Microsoft mouse in it. And
Oh,
so sometimes the kid will find, I mean, one kid will find it all year and they just start laughing. And they're like, I saw your mouse trap. I'm like, that's funny.
yeah.
It's funny. I'm gonna try that.
Yeah. Yeah, I don't know how to get that to pipe through that. So
Usually it hooks up fine with.
I mean, I'm very good at I have the USB. Is that for the camera?
You have USBs?
Let's see how there's a USB here.
Yeah.
If I unplug the USB, does that
Did
take
you turn on the USB? Did you click the mute button?
No, I didn't. When you hit mute, it goes red. So like
Oh.
yeah.
Did you unplug the USB?
I will.
You try that.
Here, okay, when I unplug the USB, we'll see if the feed goes away. Look at the US. Look at there goes my feed.
There it goes.
Yeah, that was the.
Could you try to change
I'll plug it in.
the camera? Well, do it without the, because I switched it to HDMI and so.
Okay, so video. Now I don't have the. Now I can only come out of the camera on the laptop. So, all right. I think kind of what we did was fine.
We have
Yeah.
another team, but they don't have any college people with them.
They do.
Oh,
They do?
Yes.
See,
Two
you
of the
just look
three
too
here
young for
are
me to
college
know.
students.
It's okay. You're gonna be happy about that
When you're
one day.
45, they love it. Probably 20.
Okay, that's a my problem thing. I need to learn how to recognize age better. Okay.
Okay, so is this everyone?
Yes.
Okay, so students, we want you to introduce yourselves, what grade you're in, what do you plan to do after high school or after college,
And what your project is.
and then what your project is. Go ahead.
So my name's Lauren Freed. I'm a sophomore. I have no idea.
In high school or college?
In high school.
Sorry, I'm in high school.
Okay.
I have no idea what I want to do.
That's okay.
But
Me neither.
What did you want to do when you were a sophomore in high school, Nancy?
Oh, I already knew I wanted to work for NASA as a sophomore in high school. But I knew in 6th grade what I wanted to do. But yeah, it's different for everyone else.
I'm a freshman in college, and my major is mechanical engineering.
Go on.
I'm Luke. I'm also a freshman in college, and my major is mechanical engineering.
Awesome.
Awesome.
You guys know me from last time. I'm Kenny, master's Purdue.
Okay.
Matt, teacher.
All right.
Okay, what do you want to be after you're a teacher, Matt?
Oh, I don't know. I've been having conversations with AI about that. Like, what?
Retired.
Okay, what project are you guys working on?
So yeah, go ahead. Talk about
Yeah.
what project you have.
So I'm doing making a lunar jumping robot.
Okay.
And then same thing I asked the other team. Are you planning to work on all 4 parts, or are you focusing on just one of the or 2 other parts?
All 4 parts.
Okay.
There are 2 members that aren't here tonight that are at
Okay, I think yeah.
play practice. So it's not just Lauren and Lennox and
Well, no,
Luke.
I figured that too. Yes, yeah. Because the thing is, in the requirements, one of the things it does is it has several different parts, and it also says, hey, this is the number of recommended team members. But we've had some teams that just focus on parts of it. So go
Okay,
ahead
tell
and
us about it.
Yes.
Yeah. So
Whoa. Can you share that with me? You said share Matt Hare, and I'll put it up on
Yes.
here. This would be great. They've got a really awesome CAD model here that I'm having them share with me really quickly, and then I'm going to pull it up.
Excellent.
Was it not hooked up to?
Yeah, Eleanor did it.
Oh yeah. Oh, that makes sense. You don't have permission.
Okay.
We can just hold the screen up to here. Watch this. All right. Okay. So can you guys see that okay?
Uh-huh.
All right.
Yep. Tell us about
I
it.
can see it. That looks good.
Okay, so each of the legs is kind of like a sliding mechanism. So the whole robot's gonna, once it launches, we're like trying to figure out a way so that it lands and it won't break. So we're gonna have it telescope in with springs that would help cushion the blow and like allow it to regain stability when it lands on the ground. And then trying to explain the middle part.
Oh, so is it launching open and then when it lands, it compresses?
Yes.
Yeah.
Oh, okay. Nice. Oh, Glenn has something I think he's going to show us.
So is that a tension spring in the middle? So like you pull on it?
Yep.
Okay. So as you stretch that spring, the legs kind of come down, or not legs, but the those side pieces, and then it releases somehow to make it jump. Is that right?
Yes.
Excellent. Okay. And so how do you want to stretch that spring?
We were thinking about adding a motor to it so that would gears would spin, causing the legs to compress, and then we would set like either a timer or have like a mechanism that would, once it's like turned all the way that it can, that'd launch up and spring out.
Very good. Okay. And I like that idea.
I'm orbiting it now.
Yeah. How do you and so have you figured out, so you've got a string that tightens up and stretches a spring. How do you want to make it release?
Bad connection going here, guys.
Oh, is that me? Is that a me problem?
Everybody's frozen.
Okay. No, we still see them and stuff. It may be.
It might just be you, Dave.
Yeah. Now I got you.
Okay. So how do you want to release the tension in that string?
We're still figuring out and like coming up with ideas that allow us to do that. And right now this week we decided what type of mechanism we wanted to do for like the legs, the outside legs, but then like this week or like the next following week we were gonna discuss mechanisms that we can use for the inside, right?
Yeah.
Okay. So a comment I gave the students in the last one. Does anybody fish?
Mm-hmm.
Okay. All right. So think of when you are reeling in, pulling it in, right? You're engaging a gear, and then you flip the baler over, and then you cast. That's exactly what you want to do here. Does that make sense?
Yeah.
So when you flip that baler over, it releases the gear and it allows it to spool out, and that's how quick you want it to be. Mm-hmm. So I don't know if I don't want to tell you to take apart your fishing reel to see how that works, but you may be able to find it on the internet how that works.
I have some that for my girls that I took apart this summer a bunch of times just to get them all going for a fishing trip that we take every year. So I'm like, I know exactly what you're talking about. And I'm like, it's very clever how that works.
That's cool.
Are you thinking like an open-faced one or like the closed-in one?
You could do either one. And I don't know which one is better.
Because the closed-faced one has a pin that sticks up.
The closed system is simpler.
Yeah, and that pin, when you push the button, the pin drops down, but then it pinches like the spool kind of pinches the line so that when you let go with the thumb, it lets go and it spools it out.
Yeah.
Oh, that's good. See, I have never taken one apart, so that would be awesome. I think you guys all right, you've got the right guy to talk to in front of you. So make him divulge information, okay?
Just it all apart.
Okay.
The question I have is, what about like your control system? Have you guys decided what you're going to use to control it? You know, what system are you using, like Arduino, Raspberry Pi, or something else?
Yes, we were considering using Arduino.
And what all we have in the Arduino is control? Just
the motor system and setting like a timer, figuring out how long it needs to compress and stretch out before it unlatches.
Okay. And then what about things like the camera and like power? Are that going to be controlled somewhere somewhere else or another system?
For power, we were thinking about using solar panels.
Yeah,
solar panels, and what else?
Okay. And then what about the camera?
For the camera, we were thinking about setting it in the code that once the robot jumps to figure out how long it takes for it to reach its maximum apogee, and then tell it to take a photo then, or like a series of photos as it's descending to get better images of the land.
Okay, so it's going to be programmed. All right, that's a cool way of doing that. Nice.
Hey, Glenn, can you show the pictures of those motors that you showed the last group?
You bet.
Spark Fun.
Hold on, let me share. Where's my share?
This was cool. It had a 48:1 gear ratio on it. So, and it had like an encoder built into it so it can count how many rotations it does too. It was really neat. It was pretty cheap, like $14.
Okay, you guys can see that now, right?
Yes.
Okay, so what were we looking for? Oh, geared motor. Okay, so I was looking at this one. Let's see if there's some more here. Oh, look at that. There's a whole bunch more. And so by getting some of these geared motors, I've seen a lot of students using this one. I've seen some of them using this one. Oh, that one's kind of pricey. I wouldn't get that one. Here's another one for $12. You can get two of them for $28. So you can get some pretty small motors to be able to do what you're looking for. Oh, look at that planetary gear motor for $7 there. And then you said Arduino. So I'm on SparkFun, okay? And the other thing that's kind of cool about it, let me show you something else. If I go to this one, you can go to the data sheet. And okay, so for this one, it gives you all the dimensions so you can put it into your stuff, but then it'll also give you a lot of other information about it. Now on this one, I thought it would give me let me go back.
Code.
Add wish list, data sheet, pin out. It tells you how it's pinned. Some of these will also give you information of how to, oh, there, data sheet pin out. Now, it'll also tell you what the coding is that you need in Python or in Arduino. Oh, documentation.
Yep. Yep.
I bet you that's it.
They all do that. Yeah, absolutely.
They all do it.
Yeah.
Okay. You have to hunt for it sometimes, but it's there.
Don't worry, we'll have AI do it for us.
Oh, there you go. Okay. Yeah, and the point is use your resources. Don't think that you have to do other stuff. Okay, and then you said Arduino. And so here you've got some bigger ones. Inventor's Guide. I think you're looking for something pretty small. You might be looking for this Arduino Fio. I don't know if I'm pronouncing that right, but my point is, you can, if you go to SparkFun, they've got quite a big selection, and they also have a lot of services that'll help you with the either the programming or how to hook up different equipment. Okay.
Yeah, we got it.
Okay, let me stop sharing here.
And I think they give 10% off for schools, at least they used to. And
I think you're right.
And they used to also have somebody, because the person actually worked for Hunch once, that would answer the phones and answer any questions you have.
Yeah. Oh, they've got a lot of really good help. So yeah, don't be afraid to ask them.
Yep.
Okay.
So I have a question for you. The body that you've worked up there, you're going to print this, or are you going to build it out of other materials?
We were gonna print this.
Okay. In PLA or something like that?
Yeah.
Okay. So you should be able it, and here's why I asked. When Glenn was showing those things for you to consider, for instance, that small motor. Um, if you kind of think about this backwards, like how big, how much weight do you need? Once you have picked a particular electronics package and you know what its capabilities are, then the design, the size of your rocket, et cetera, can be determined accordingly. There are a lot of teams that I've been looking at around the country who have systems that are going to weigh, maybe a pound and a half total. Um, and that's a very manageable mass, if you will. So I would definitely do what Glenn says and look at those things. Go ahead and make an order, get some stuff in, and then you know what your capabilities are. You can limit the weight to just what you're able to produce with the system you have. You're probably going to end up using maybe like a 9-volt battery or something with this. So, I mean, all of that together, that's just a good way to kind of break this down and say, how much mass are we launching, right? And you'll know, and it won't be significant.
So, notice here, I've got this little spring. I got it over at the hardware store. If you go over to Ace Hardware and walk in and say, hey, I'm doing this project for high school, they're going to go, oh, let me help you. And then you'll say, I need a spring. And they'll take you to this bin with 20 drawers, and each drawer has 20 different springs in it. And this one, I don't think this one would be strong enough, but if I had two of them like this, it might fit your need. Does that make sense?
Yeah.
The hardware store, they've got this. It doesn't matter which one you go in, but they all have a similar kind of set of drawers of springs. And the biggest value is that I can do this and say, that's not strong enough. Or I can pull on another one and say, that one's too stuff, it's too stiff. You see what I mean?
Yeah.
And that's part of the research, is going out and finding parts that may work for you. And sometimes that means they won't, but it gives you a direction to start. Okay?
And you don't have to start with 3D printing it because you're not quite sure on the size. So make it cardboard, your square top or rectangular top, make it out of cardboard and put the stuff in, see if it fits. 3D printing should be your last choice, right? Because you don't want to waste material, and who knows what size you'll need at the end.
I have a picture of it.
Do you have questions for us?
Do you want to tell them how you make that cardboard?
No more thoughts?
No, none.
Okay.
Thanks, team.
Don't be afraid to send us some emails. We
Yes.
answer emails as quick as we can.
Here's a video
look
of their
at that.
cardboard model.
Oh, there
nice.
you go.
I
You
like that.
already-
Oh, that
looks
is
really
good.
cool. So you guys have already done a
A
cardboard
model.
model. I think that's smart.
Yeah.
Yeah,
I think that
and
gives
that's
you
what
a
you want to
great
do.
beginning.
Very good.
This is
I like
college
that a
kids.
lot.
Yeah.
Good job.
Yeah, good job.
The college kids came out. They brought in all this cardboard one day. We're like all gonna make models, and I was like, "That's awesome! What a great!"
That's the
Yeah,
way
and
to do it.
definitely when you guys go to CDR, show those models, because that's always
Yes.
good to show how the progression, because that's just as important as seeing the final product, because you learn a lot from those initial projects.
I like your prototype. That looks cool. Good job.
Very nice. Yes,
Absolutely.
good job.
It looks just like your drawing.
Yeah.
Yeah, it does.
Yeah.
Huh.
Good job.
Do
Wow.
you think the box on top needs to be that big?
No, we were gonna scale down the size of the box. We just didn't know how big we were gonna make it at first, or how big
Sure.
the needed to be inside of it.
I think that's smart. Give yourself room to shrink, because I think the kind of stuff that you're talking about, whether it's an Arduino and a battery and a camera, they really don't take up very much space. So I think you're on a very good path. I like how you've started this, and it looks like you're going
Yeah.
in a good direction.
You bet. Well, and thank you, college kids, for joining. That
Yeah,
is
good job.
so awesome. Yes, we really
Yeah, and
appreciate
you guys
that.
said, and you said there's other team members?
Yes.
Okay, I'm gonna tell you what we told the other team when we're doing this on Zoom. We know the weather was an issue. The other teams can also join on Zoom. So
Right.
if this happens later on, just want to pass that along too.
Respond to me. Anyway, yeah, go yell at them.
All right, very nice work. Good job.
Yeah.
Thank you.
Awesome. Thank you guys too much.
Okay.
Okay, talk to you soon.
Do you want some? I think. Well, we have another group here. It's just the college. I think maybe the weather. I don't know why my students. A couple of them. I know their group.
Yeah, I mean, even if it's the college students, we'd like to hear.
Yeah, no. Yeah, come on in, Mandy.
Yeah, we still want to hear them. We could provide input to them. Yeah.
Oh, totally. Yes. Yes. So this is Mandy. Mandy's
Mandy.
Hi, Mandy. She was the one that was 3D scanning with the kids last week. So awesome. I want to show you a quick video of all that. It was so good.
What year is Mandy?
Mandy is a junior.
Okay, very good.
Yeah, I think she came with us to Cleveland this summer.
Okay, I thought so. Oh, that is cool.
So this is for chess, is that right?
Yeah, yeah. So she could maybe explain kind of what
they're doing.
Great.
Okay.
I have never done any scanning, so this is
me
new to
neither.
me.
That was my first experience with it. I'd seen people doing it, but like didn't quite understand.
Yeah. Okay.
Yeah.
So what kind of things are you scanning there, Mandy?
Oh yeah.
So their idea is kind of
oh, nice.
For their
that's cool.
Like idea. So they ran out of the chess, motorcycle chess. They ran out of little seashells to use for their pawns, and they're coming up with ideas of trying to find new ones, or they can like design more. So we have a 3D scanner here, so I'm just like, why don't we use that? I had no idea how to use it, so I was asking.
So you had to learn. That's awesome.
Asking the front desk.
Yeah.
And we figured it out. So
it was awesome. I thought it was such I mean, you see people, using that technology, and it's like you got to actually put your hands on it and like do it. It was really cool.
Okay. So you've got some seashells for different pieces. So is it going to be seashells versus seashells, or is it going to be seashells versus tree seed pods or something?
So they went to Goodwill and they found a bunch of little toys, and was like sea animals. So they found like dolphins, fish,
nice.
Seashells. So they're gonna try to do sea animals versus land animals.
Oh,
I think that's great.
That is
wonderful. That's so cool.
Okay.
How neat.
So do they want to I take it they want to 3D print all of their pieces, and that's good. Do they have an idea of how they want to make their board?
Yeah, just a little correction off of what you said. They do have most of their pieces from the Goodwill like shopping spree, but from what they want more of, they're gonna 3D scan it and then print it. As for the board, we kind of went off the idea of a fabric board, and then with that board, you can kind of scrunch it up, and that can carry all your pieces.
Okay, so it's a fabric board, but how are they going to keep it rigid? What are they thinking of doing to make it at least rigid? The fabric board is a neat idea.
So yeah, it should just like lay out on a table. And then around the outside, they're gonna have like a little string, and then you can fold it up, pull the string, and it should come into like a bag, and they can
Okay.
That's a great idea.
And for the fabric, is the thing that this is recycled, they'll use like astronaut t-shirt or something that's already there for the fabric?
Yes. So we went a little scavenging through our pile of unused fabric that was just in the reclaim bin. And we found some like green and brown to use as their earth.
What's the matter?
Some blue to use as like water, so it still goes along with their theme.
Yeah.
So I thought that was pretty cool.
Yeah,
That is cool. Okay. Now, here's another thought. What do they, so you've captured a piece. Where do you put that piece?
That's a good point. We actually didn't think about that.
Okay.
Yeah.
And so,
That's a real, oh man. Oh. What
and
are some
so,
really good ideas that other groups have about that one?
okay. And so remember, so we're telling you that the largest, it can't be any larger than 12 inches by 12 inches, but that doesn't mean that it can't be thicker, right? Also, and consider, because it's 1/6 gravity, some of these pieces may be so light that just breathing on them might make them skitter across the table. So keep that in mind as you're designing this board and how it's going to interact with the pieces. Okay.
Yeah, so do you know what like snap connectors or buttons are?
Yeah.
Yep.
Sew that onto their board and then put it on the other end of the piece, and then you could snap it in place.
I like it. I think that's a great idea.
That's a good. Yep.
That's a great idea. And here's a suggestion, because you've been talking about doing, an additive manufacturing project. You could also consider repurposing some materials that might exist, right? It's like chests from trash. It's actually not necessarily recycling, but repurposing. So, you could use snap buttons if you can justify the fact that there would be that material available to the astronauts on the surface of the moon. And because I'm just saying, you have a little more flexibility. You can do part of it additive manufacturing, part of it just from repurposing the kinds of things that the astronauts would have available. Because I mean, what's the essence of the project? It costs a lot of money to send mass to the moon, right? We're throwing around numbers of $1 million per kilogram of launch weight, right? So every kilogram of plastic or other material that's used for packing, et cetera, is sitting on the moon, and it's the most expensive trash that's ever been created, right? Repurpose it and use it. So you made a great suggestion. Maybe you could integrate both of them into the design.
Mm-hmm.
So what if an astronaut chose to take a button-up shirt, a snap shirt? Now it's trash after they use it. So you have the possibility to repurpose those snaps potentially.
Yeah.
Okay. That's a good one. I hadn't thought of that.
And I have to say again, I love the sea animals versus land animals, because
I do too.
Yeah, Dave brought up a good point in that lots of teams are using a space theme, but think about the astronauts. They're involved in space. Everything they deal in with space, and up on the moon, sometimes they want to be reminded sometimes of things other than space, because some teams make rockets and stuff. So these land and sea animals are neat in that it reminds them of something back home that you don't necessarily will see on the moon, to see in the land animals. So that in itself is very, very, very cool.
Another one to think about is, if each astronaut could print out something like their own family. So my family versus your family. See, all of the pawns could be your cousins. See, Uncle Joe is the rook, that kind of thing. My Aunt May, she's a buster, She'd make an excellent queen. You see what I mean? So anyways, just thoughts for you.
You can 3D scan them in.
Yes, you got the scanner. You can do that.
Great idea.
Okay. Any other things you guys are thinking about for this?
Yeah, just 1 second.
Mandy's
Okay.
writing.
She's taking notes.
So good.
Okay, so they had two kind of major questions. I guess the first one was really covered, but they'll be building this on the space station or on the moon.
On the moon, yes.
Yeah.
Okay. And then the second question to go along with that is that do they need to be worried about any kind of off-gassing from printing?
So
Within reason.
yeah. So what I've told students is everything you do is off gas, but it depends on the quantity. So they may want to use, for example, there are recycled filaments that you could use to make that. And then just to let them know, like I said, I've done off gassing for my experiment. What they do is look at the quantity. So I may fly a fluid module and they say, okay, you can fly 50 of those before the off gassing becomes an issue. So we wanted them to be aware of it. But yeah, it's not, some students are making it a lot of bigger deal because they realize, 3D printing off gases, so they're avoiding it. When we don't want you to do that, but just be aware and identify how much it is. Yes.
All right.
And Nancy, didn't you say they have glove boxes? They'll probably have glove boxes.
Yeah. So some of a lot of our experiments will run in a glove box, and within the glove box, if they're doing something that off gases, they can actually vent that into the space. In fact, one other thing that you just remind me of, if you ever notice when the vehicle, when SpaceX or Northrop Grumman, when they dock with station, notice that they usually have a mask on, because when they first open that, after that being secure, all that stuff combined together off gas, when before they first initially takes it out, and then they acclimate. Mm-hmm. So a lot of it is just for the things just being kept together and stored and everything like that. Mm-hmm. And then there's somebody else. Okay, who's the other person? Did we already get introduced to him? I see somebody next to you. Right. Yes. Okay, cool. Any other questions? Either they had or you had?
So it will be recycled filament, but can it be bought or does it have to be made?
You can buy it. That's fine.
I would say if you're planning on making an order for something like PLA, you can purchase spools of recycled. And I know a lot of teachers that are doing that, and that would at least be able to give the credibility of saying we're using recycled plastic in our prototype, right?
There's a few teams that are trying to recycle their own plastic, but that's a real complication. So not required, but it's nice to have.
Yeah, they had talked about it and they kind of came to the conclusion that would be kind of out of their budget to try and do something like that.
Yeah,
that's true. Now, consider though, at the university, it may not be. If you guys are interested in that, I've seen lots of videos, maybe you have too, about how to recycle plastic. I was a little bit surprised. The Mountain Dew bottles now say 100% recycled plastic on them.
That's pretty cool.
And I think Coca-Cola does that too.
Yeah, I'd have to check. We do have a 3D makerspace, or like a club that does that. I don't know if they have one, but I could always check. So that'd be interesting.
It's worth asking. If they have one, they'd be able to brag that they were supplying you for it. So that'd be something else would be cool.
Any other questions?
I love you that you're taking notes. That's awesome.
I want to say that Nancy made a really great point about the astronauts like missing home and everything that they do with space. And like I'm doing my master's in aerospace engineering, and that's something that I've never once thought of. Like, I try to make everything space themed, and but you're so right. Like, if I was on the moon, I would get so homesick, and probably seeing things like land animals and sea animals just means so much to them. So that was a great.
Yeah. Oh, it's true. In fact, one of our projects in the health and biomedical was trying to find things to from the mental health of astronauts, just in general, having stuff that tells them more about home, helps them out, because they're so far away and stuff. But yeah,
even color. We made their galley table green, and they loved that it was green instead of gray.
Yeah, that's right. The government makes everything gray, so it's
White.
white. Yes.
I can't remember where they got the idea from, but I know it was from our initial talk, when they had asked some questions from you guys.
Okay. Well, good.
Yeah.
All right.
All right. Well, that was all I had. Thank you for talking with me.
You bet.
Yeah.
Thank you.
Thank you for helping out.
Yep.
And don't be afraid to send us emails, right? We can kind of hook up online and figure out what kind of things we can help you with. Okay?
Okay. Thank you.
Anytime.
You bet.
Have a great week. Thank you.
Take care.
You have another team, Matt?
Yeah.
One more.
We have one more.
So
Yeah, and they're doing the chessboard as well.
Okay.
They have a different tack at it, which is kind of neat. This one's exciting.
Well, that's what's neat to see when you have multiple teams.
Yeah,
and they work different ones. It's cool.
2 and 2, and so it's fun to just see how they're similar and also how they're different.
Hey guys, how are you doing?
Good. How are you?
Good.
Excellent. You have more stickers on your computer than I do.
Yeah, I recognize the NASA one.
I think that's a sign of how nerdy you are. Like, the more stickers you have on the back of your truck, the more aggressive that people.
That's right.
So stickers on your laptop, it's equal to nerdy.
Right. So we wanted you guys to introduce yourselves. And I know some of the students are missing, but just go ahead. And then tell us your name, what level you're at, high school, college, and what do you want to do in the future?
My name is Grant Bosilevich. I'm a junior in college, and I want to be a HVAC engineer.
My name is Sievert.
Pretty cool. Okay.
UW Platteville. And in the future, I would like to do design work for either defense or aerospace.
Okay.
That's cool. Okay.
Oh, hey again.
And he's all right. So we hear you're working on a chessboard, huh?
Sure are. So we've got 2 high schoolers in our group. Unfortunately, they could not be here tonight. They are both freshmen, so it's been pretty fun working with those guys, seeing what ideas they have to come up with. As a general idea of what we're looking at, okay, we're doing a recycled chessboard, right? We wanted to the flair, if you will, to our projects. We wanted to add multiple games into one board, right? We want it to not only have chess, also checkers, also Connect Four, and then we kind of tie everything together so that, okay, what if an astronaut doesn't like chess? What if they don't know how to play chess? Okay, there's other options that they can do. And how can we make this out of recycled materials, right? So that's the main idea for the project.
Putting in Connect Four is actually really creative. I'm
trying to think, how would you do that? And
I don't think we have anybody else trying to do that. So that's unique.
Yeah, and
I'm excited about that.
Yeah, and Glenn, Matt has a Connect Four game there because I had fun when I went and visited because I had one of his students I was playing. I beat him like 2 times in a row. But
is it big?
No, it's just a regular Connect Four size. Four size.
Wow. Okay. So that's actually kind of cool. So how do they want to do that? Do they have thoughts on that?
Okay, Glenn, you put your hand up, and I think it's.
I'm sorry, I must have done something.
No, you raised your hand. You
Thanks.
have that little thing set up.
Oh,
I
because
disabled
I
that.
went like this. Let's see if
Yes.
it'll do it again.
Oh, it did it before.
Okay, keep going.
So you guys kind of starting from the top here, we have some CAD models. So I guess we'll try and show this.
Yeah, that works.
Yeah. So okay, you've got your typical chess piece, just for reference for starting to talking with the kids, and we're thinking, okay, how can we relate chess to checkers to Connect Four? So our first kind of thought was, okay, if we just had checkers and Connect Four, that's pretty easy because you're basically using the same pieces, right? So how do we connect that just circular piece to a chess piece? So we thought, okay, what if on the bottom of our chess piece we had a cavity where we would add some sort of threaded rod, right? And that threaded rod would then go connect into basically our domino piece. It would go into here. And we were kind of able to demonstrate how you'd use heated inserts and stuff like that. Now, we might not deem that as recycled material, right? So we might have to look at, okay, could we, instead of your traditional heated insert that you would use with 3D printing, could we use the random nuts and bolts we have laying around? Everybody has a junk drawer. Okay, probably going to have one on the moon, probably going to have one on Mars. Can we use that in replace of a heated insert? So that's how our chess piece would connect to our checker and Connect Four piece. And then as far as connecting to the board, the kids came up with, okay, what if we had some sort of geometry that would be able to lock in place? You know, you'd be able to pass it through into the board one way, turn it, and then because you've turned it, it no longer passes back through. And we can kind of see that idea right now. We just have a simple hexagon here on the bottom of that piece, and that would connect to this guy here. If we grab a cross-section view, we can kind of see that, whoa, going crazy
Yeah.
here.
No, that looks really smart. I like what you're doing there.
So, we can kind of see that, okay, the polygon will pass through, but as soon as you twist it, those edges will be caught on this top edge and it won't be able to come out anymore. And if we wanted to get really fancy with it, could we have some sort of, spring in here through a hole with a pin pushing it up so that, okay, no matter what, it's always going to be held tightly secure. And that kind of idea is what would hold your chess piece, your checker piece, and maybe even your Connect Four piece.
So, question, if they push it in and twist it to lock it in place, when they make a move, do they have to remember to untwist it, pick it up, and then move it and twist it again to get it in?
Yeah, it would just be a matter of, okay, can you actually pick your piece up? If not, you'd have to twist it to align it with this hexagon geometry that we have here.
Okay. And if it's just one twist, and as long as it's like righty tighty, lefty loosey, as long as you know that, then okay.
And if there was a spring to it, would make it even more intuitive because if whenever you get it aligned, it would spring right up.
Okay.
The piece would pop out.
So are you planning to print the board as well?
So we've talked about that, and Grant will touch on the board itself in a little bit here. We were thinking, okay, depending on how much 3D printed material is allowed, we could either do the entire board or we could just have these little inserts, kind of contained like themselves. Like, so just like how you'd have a keyboard, you can switch your keys on a keyboard. What if it was the same thing? Okay, say something bad goes down with this connection, we have to replace it. Okay, instead of replacing the entire board, you can just pop that one out, throw a new one in.
With that. And so there's a requirement for it to have at least two colors, and you can have more if you want. But by, however you want to make them interchangeable would also allow for changing of colors as well. So that sounds like a great idea. Now, the other thing you can do is instead of having a spring, it might be that you can 3D print something, the plastic, so that it pops in or out with a little bit of spring force.
Yep. Yeah, that's a good point.
I like where you guys are going. I think this looks smart. Now, if you have all of those pieces of the board, that also means that you have to come up with a way for them to lock together so it doesn't fall apart every time.
Yep.
Do you have thoughts on that?
We have not gotten to that point quite yet. Unfortunately, our students haven't had a lot of availability to come to our meetings, but we are getting there, and that's going to be one of the next points we tackle. We've been focusing our last meeting a lot more on how the box actually looks rather
Yeah.
than chess pieces.
Mm-hmm.
Okay. And that sounds good too. And so now we've said that it needs to be 12 inches by 12 inches as the largest. That means you can make it smaller if you like, but we haven't said anything about the height. So you guys can play with that a little bit. Now when you're playing and you capture a piece, where do you want to put that piece?
That's a good point. We haven't really actually thought of that. I guess, Grant, you can kind of go into what our initial box design kind of looks
Oh,
like.
very good.
There, over here. So our initial design is pretty much we have the chessboard that'll sit. Oh, that was me. That'll sit on top of the box like that, and the box will be made out of. I think we're doing right now aluminum sheet metal, and then the very bottom will have some hinges, and then a little like locking mechanism on the other side, so that we can open it up. And when you're not playing chess, you can turn it upside down, put all of your chess pieces Connect Four and all those stuff inside the box, then lock it so that when we're at Mars or the moon with not a lot of gravity, the pieces won't be floating away and they'll all be stayed together.
I like that. And okay, so an aluminum box out of sheet metal. Are you guys thinking about how do you get a sheet metal leftovers on the moon, do you think?
That is something that we are also still looking at and figuring out how to do because we could redesign the box to be 3D printed using cutting it into 6-inch sections as that's what's the maximum allowed.
All right. So one question I have is the box, and maybe I missed it, is the box the actual board they're playing, or is the box because you have the sides there? I'm trying to.
So the board will be sitting on like the top part of the box right here. It's just we haven't modeled it yet. So the board will be part of the box. So it'll all be
okay. All right.
Okay. That sounds good.
Yep.
Now I see that you've got hinges in there. Are you going to buy those or where and part of what I'm suggesting is don't 3D print them, right? Go ahead and get yourself some hinges. I didn't want you to have to go out and print those. I think it's much better when they have to assemble when they just purchase that kind of thing. Okay, that sounds good. Okay, just a thought. I really don't think that we're going to send cans of Coke to the moon, but that may not be so far off. Yeah, and so what I'm thinking is you could make this out of aluminum cans. Does that make sense?
Yeah.
If I was on the moon and they'd send me a Mountain Dew can, I'd be okay with that.
Surprise, surprise.
All right. Other thoughts you have with your team?
David, you've got a couple of thoughts?
Yeah, so that's basically where we're at in the design phase right now. Hoping to jump into, okay, we're basically finalized on how our pieces are going to connect to each other. We just last week finalized, okay, what theme do our pieces want to be? Obviously, because we don't want boring old chess pieces, right? So we were about, okay, the kids want to do something space themed. So we were thinking about, okay, can we look at different rockets that NASA has launched, and kind of model, okay, this one will be the king, this one will be, and even looking at things outside of NASA, right? Okay, could Sputnik be the pawns or the rook or something like that? something that astronauts are going to eat up and love, right? So that's where we are with that. Other than that, hopefully starting to actually get some two-size prototypes done with our pieces. How are they going to connect? Is this possible? Can we actually use trash like old nuts and bolts for this? And then I guess some questions for you guys here that I'll jump into. Is off-gassing something that we're worried about? Is that something that we're going to have to look for a certain material of plastic? Does this 3D printed plastic have to be a recycled plastic?
Okay, so with off-gassing, yeah, this has turned into, I think, a bigger concern. What we want you to be aware of it. Everything off-gas, and I've worked on several experiments, and same thing I told the other student with off-gassing. They know it's done. So what usually is done is NASA says, okay, if you have this one widget, you can take 100 of them up before off-gassing becomes an issue.
Okay.
We have a 3D printer up there. It's done inside this glove box where after it's done, they're able to evacuate the air. So I would not worry about it, but we do want the students to be aware. And then with the filament, there are recycled filaments that you could use in that. Yeah. And I think you had another question with off-gassing. Did I answer all of them?
No, you answered both the questions.
Okay.
No. Is there any restrictions on how much of our final prototype is actually 3D printed?
No, you can do the whole thing 3D printed if you want. I mean, it's nice to be able to throw in some other things that.
Of course.
One other comment for you though. Consider if you were the astronaut on the moon and you have lots of gray dirt and NASA things all around you. Do you want anything to remind you of being an astronaut on the moon? Or would you rather think about your friends and family and different things that are back home?
Back home. With regards to the pieces you're making. Because remember, they're in space. Everything around them is space. Everything around them is NASA. So would they want to see more rockets and stuff like that, or would they want something else that reminds them of home?
That's a really good point. I hadn't thought of it like that.
So we'll just leave it at that.
And then I guess as a final question, and I guess we kind of already answered this, like how, because we are doing the prototyping and design category, right? How much of our final products that we pitch to NASA is going to be, a solid prototype? Like right now, this could be sent to the moon versus, okay.
Proof of concept. Yeah. Goes back to what Glenn was actually saying about, going out and buying things like hinges, right?
Yeah.
It's high school students, and we don't want to, invoke an unnecessary, financial burden. So as long as you can build something that demonstrates your concept,
and going to Goodwill is good. And then you just remind me, do you guys have a chess club at the high school or even the college?
We have one at the college.
Okay, well, as the kids build it, invite them over to have them look at it, get their opinion, because these are the folks who are into it. We've been telling other schools, have the chess club come.
Idea.
Yep. And so, Matt, I think we forgot to mention that to the other team, and also the two colors to the other chess team, but tell both of them when they
Mandy's
get a good
hanging out listening.
Okay, good.
It's all good.
Yeah, when they get a good prototype, take it to the chess club, get their opinion, tell them to be brutally honest, and I guarantee you they will. I do have one question. You guys that's doing checkers, chess, and Connect 4. Checkers and Connect 4 is good, but remember, the main objective is chess. We want to make sure you get the chess and all the pieces going. Anything beyond that is bonus. It's an addition. But if you don't get the chessboard done or the chess pieces done, but you have checkers and Connect, that's not a win, I would say. You want to make sure you meet the main objectives. Anything beyond that is gravy. I mean, I love the fact you're doing 3, but just remember to make sure you meet the objectives for the chess pieces.
Absolutely. That's a good point. But yeah, other than that, that's kind of where we're at, and that's all we had for you guys. We appreciate your time.
Sure.
No, this is great. I think all the teams are doing good progress. And like I told Matt, I like the fact that both teams for both different projects are doing things slightly different. That's nice to see.
Yeah.
Just different ideas.
Now, so we've got some time here. Did you guys want to have some questions or anything that we can help you guys with?
Yeah, I wanted to give Kenny a moment if he had some questions too. If you want to chat and like if you have questions, anything like that.
I have a couple.
Yeah, he's got a couple. All right.
Yeah.
Yeah.
First
Yeah,
of all, Mr. Johnson, how many different hats have you worn over the course of the last hour and 41 minutes?
Just 3.
Just 3. Okay, I thought it was
didn't even
4.
notice it.
I thought it was 4. All right, 3. Okay.
Oh my God.
I noticed that with the high schoolers, there's a lot of freshmen involved. This might be a Mr. Matt question. How do you reach the freshmen and I guess like other high schoolers as well, but like
Sure. So, yeah, like our school does like it's called an involvement fair. So when the incoming freshmen come in, clubs in the gymnasium, and they have set up, then people they give all the freshmen like cards, like with their name on it. So and they're like, just put this in the fishbowl of anyone that you're interested in. And then I get all those and I just send a mass email, hey, we're gonna have our first meeting on this day, so, as a way to kind of get a hold of them. So that's how we market to our freshmen.
Okay.
We'll do things up in front of class, and a lot of it's word of mouth too. Like that whole group that is all the soccer players, they're just all friends. So I think that's a big one too.
Okay.
Yeah.
Thank you. How long have you guys each been involved in the Hunch program? I think Nancy said 15 years.
Yep. Yeah, I'm here about 15. I think Flo, you were a teacher.
Yeah, since 2005.
Wow.
I said
20 years.
Yeah, I met all of these guys almost on day one. I remember I took a group down to the Johnson Space Center, hooked up to a university program, and I was on the fence. And Flo walks by me with all these high school kids, and I'm like, how do I get in there? And she said, "Oh, we started this program last year. You should apply." And then it took me a couple of years because they expanded, and then I was in. So yeah, I think 2005, 2006 is when I started. And I knew everybody here. Like Dave was a teacher, right, in the Hunch program?
Yep.
Yep.
He
That's
was.
right.
Yeah, I started with Hunch in 2012.
Yeah.
So it's funny. So all 3 of them have been in the Hunch program longer than me. So I've only been in for 11 years, but they've been involved.
Only, yeah.
Yeah, it's kind of interesting. It actually kind of breaks down 50-50 right now. I think I taught for 6 years and retired in 2018. I've been doing this for 7 years, so pretty cool.
So I was gonna ask how you guys have seen really the program grow and like yeah, you guys have seen
well,
the
I
program
can
grow.
I can tell you that because I have to submit bi-monthly reports to my management. So since we just started Hunch, I just added 3 new schools. So I have 20 schools and I manage right now, in my area, Glenn and the neighboring states. When I started with, the year before I took over the Platteville team, I had 3 schools that were all doing hardware. And then the following year, I got Platteville and East Troy. And then it has slowly grown for me.
Yeah.
Yeah, and when I started, there were just 3 Hunch employees, and now there's like 25 of us.
And we need 25 more.
Yeah, we need 25
Well,
more.
yeah, and we've added several other programs because when I started, there was hardware and extreme science, and then design and prototype, biomedical, software, video, culinary, and then Hunch Academy is the other one that we also promote to teach. This is a way of getting like 1st through 8th graders, and it's more that the teacher works individually, but we have like lesson plans, and it gets the students at the middle school level into Hunch. And usually what I do is I tell teachers, if you have a feeder school, that's a good program to let the teachers know about, Hunch Academy, and then from there they can come in.
Yeah. So that's like what I was getting at, like how the different projects have grown. So first, real quick, do all of the high schools have partner college schools that provide mentors, or
No,
is they're kind of unique in that
you
sense?
guys are an exception. In fact, we're looking at ways to do that more. So you guys are great. We're doing that. Yes.
Yeah.
I'm working on getting Rochester Institute of Technology to do it. Because I have you as a model. And now I have a Hunch student who goes to RIT, and she has a club just like you guys, and they're getting involved now.
Good. And then I kind of wanted to ask just what you guys have all been in this for a long time. What has been like a project that you really liked or that really stood out to you as like just wow?
Oh, I don't know if I guess. I wouldn't say wow, but one thing I've always wanted to do, and I got to do it this year, was actually come up with a project and then work it into Hunch. So that's the I just drew a blank on it. The plant one. Because I'm with the plant growth nano lab for plant growth, because I did that last year as a design challenge for college students, and then based on that I was able to work and bring it to the high school level, where the objective is for students to come up with an experiment that we could drop in our small drop tower in 5 seconds. So for me, that's kind of, yeah. I mean, I've helped with other projects, but this one is cool. I mean, we've had so many amazing projects over the years. I think it's hard to pick just one, because every year, like I said, the students amaze us. And like, I'm only seeing the students in my region. I know Glenn and Dave, they're able to see everyone. And then when we go to the final design review and you see what other schools have done, the thing I find interesting is I love listening to students and says, well, we eliminated this design because it didn't work. And then another team has that as their focus. And the kids are, how'd you get that to work? So it's great seeing that.
My favorite thing is watching the students actually do. And one of you actually mentioned that you wanted to work for NASA. Well, we've had a lot of students work for NASA. And right now I'm trying to hire one of my past students to take my place so I can retire. So I love that you guys come along, and then you are the next generation, and you will be able to take our place, which would be awesome.
Send us a resume. That's the answer.
Yep. Oh, and that's the other thing is,
absolutely.
Yeah. So I was just told, so the other thing is NASA internships. This is for all you college students there. I was just told we have till the end of January to put in the projects for the summer. And I always bring in, well, last summer I had 14 interns funded a variety of ways. So I use Space Grant. Wisconsin Space Grant is good. And then other funding from projects. So I definitely recommend intern.nasa.gov. You want to look, and it's not just Glenn, all the centers. Johnson has internships all over the US. They have internships, and that is a great way to get experience and see what we're doing.
And Nancy has them work on some of the, so occasionally they will take some of the Hunch projects and turn them into intern projects.
Yes, I have a collegiate challenge every summer where I take one of the Hunch projects, add a little complexity, and have the students work on those. So
and interesting enough, we had a Hunch teacher take part in the world's largest analog. She was in Poland, and she did the chess project there. Her students designed a chess from trash. Then that's what they actually did in this analog to see how their project was applicable in an analog situation.
So speaking of internships, one of you's work at Johnson Space Center, correct?
Glenn.
I do, yeah.
Oh, well, that's convenient. So I have to schmooze you a little bit because I have an interview for a Pathways position on Thursday. So if you know the Flight Operations Directorate, feel free to talk.
Nice. Yeah, because Pathways is something else I was going to mention. If you're sophomore or above, the Pathways is the path NASA is using to bring in new employees. You intern a semester, go back to school, intern a second semester. Then when you when you graduate, you're able to, NASA brings you in. We've been bringing lots of students in that way.
That's the goal. That's the goal.
That's awesome.
Yeah.
That's really cool.
No, I think that this is like a really awesome program. I think even without the name NASA attached to it, just the opportunity here to have the college students mentor the high school students and to give them real engineering work that's like meaningful and genuinely develops their engineering skills is incredible. And then just when you attach NASA to that and you give in all the resources that NASA has and you provide the opportunities that NASA can, like it's
And then I'm going to recommend to all of you guys in this room, same thing I tell the high school students, be sure to include this on your resume, that you mentored high school students working on NASA projects. That in itself, I know with high school students, they'll get interviewed because not that many people can say, I worked on a project for NASA.
Yeah.
Ooh,
Okay.
Yep.
Notice, so all of, whether you get an internship with NASA or not, go to this one, right? So this is on the Hunch design webpage. And here, NASA L Space, these are 2 classes that you can take from as a student. And I can't remember I don't think they cost anything, but the idea is that they are teaching you how to prepare projects for NASA. And if you complete these, it gives you the potential, they put you on a path for an internship. Okay, so go to NASA L Space and apply to them. Tell them that please tell them that you had some kind of connection with Hunch, and it just helps you guys out as well as us. Okay. And then there's also other listings on there for what do you call it? Just other places you should apply if you're looking for internships. I mean, there's so much going on with the commercial space programs as well. So I think there's a lot of great options for you guys. Okay.
Yeah.
And if you come down, do you have any specific questions about your pathways meeting?
They're gonna have an information session tomorrow. So other than the very vague, like, what should I try to show them? I don't have anything specific right now.
Well, so one, you're working on a program with the Hunch team by working with students. So I think I'd mention that. Have you were you on any other team projects or programs while in college, like competitions?
Actually, my senior design was with Glenn. Nancy, I worked in the slope lab with Viper.
Oh, cool. Okay,
yeah.
so that's another plus. I'll be honest, is the fact that you've interned at several NASA facilities and you have experience. I'll be honest, that's a plus because it shows you're familiar with the NASA environment and stuff. And I've been passing to my interns to do that. Definitely highlight the fact that you've worked on NASA projects, you're supporting Hunch and things like that. And then, they're going to ask you what's your strength and weaknesses. Make sure you come up with something, from that. That I'll be honest, that's a standard one they always ask, although they don't ask it that way. What is something that about yourself that you think you can improve? That's usually how they dress it. But cool.
Yeah, I don't know. Any other thoughts? I mean, there's a lot of soon-to-be engineers sitting there. Anybody else have thoughts?
Yeah, I have a question about pathways. So when I filled out the form, it said I was accepted to the next round of, I think it was like the codes, and it was like 995 was a specific one I was accepted to for the 5 facilities I was going for.
Okay.
Compared to the other number combinations, is that just specifying like the years, or is it like
I think the codes is specifying the area they're going to put you in. I know with the pathways, a lot of times they look at the resume, what you put on there, and they look to see, they look at your experience. Because I had a student she was not a computer science major, but had an interview there because she had done some work in one of the things she did is she had done some analysis doing with the computer. So I'll have to look it up, but I think the 995 is a classification for like aerospace engineering, mechanical engineering. So I think that's what it means.
That makes sense.
Yeah, I don't know that one.
Yeah, I don't know that one either. So
I'll pull up the email quick to make sure I gave you the right code.
yeah.
Mandy, you had a question?
Yeah, I noticed that the JPL opened internships or applications yesterday, I believe. And I think, is it Pathways that opens on December 15th?
No, the pathways are different. The pathways go through what is it? Shoot. What's the jobs one? Okay, USAjobs.gov is where the pathways go through, and they just had an opening, I think, for the spring. So the timing for the two of them are different. For the regular internships, that one, like the application deadline, is end of February. I think it just opened because I just got an email today saying I can start putting in applications. JPL is a little bit different because they're a NASA center, but they're also run by was it Caltech? So they are NASA, but not NASA. So theirs is a little different the way they bring in students. But yeah, I'm trying to see. I don't see where they have the pathways here. I think the pathway program is a little different. But yeah, and where you apply for it is also a different place.
The application cycles are open for about 1 week, usually.
Yes.
Spring.
Yeah.
Yeah. So the current pathways for spring 26 was only open through September 26 of 25. So it's already closed for the spring internships.
Right.
I will I will forward all of them, all of
Okay.
these in case
That's terrific.
They're giving me the time signature here to like
Yeah, probably on the end, huh?
Okay.
And if they do have any questions, I told them that they're welcome to just shoot you an email and
yeah, you guys can email us anytime. Not a problem. Okay.
Awesome. Yep. Thank you all so much for your time. We appreciate all of it.
Yeah, any questions, email us. Glad to see you guys.
Yes.
Thank you guys so much. It was nice to meet you and talk to you guys.
You too. Thank you for helping out.
Yeah,
we appreciate that.
Absolutely. Thanks, guys.
I'll send you the link, Matt.
Okay, will do. Thank you.
All right,
Thank
thanks.
you. Bye-bye.
Bye.
Okay, night, everybody.
Night.
Night, Dave.